Hello, my name is Reynolds. Welcome to Mat-073. Today we're looking at section 6.6 and we're going to be solving radical equations. So when you have a radical equation, we're going to undo. So maybe you've seen "Please excuse my dear Aunt Sally." So this is the order that we do things in. So now I'm going to try to undo the last thing that we did. So I'm going to try to undo addition and subtraction first. In this case, I would subtract off the 4 first to be my first step. And over here, I'm going to teach you a technique. The very first thing we want to do is isolate the radical. So if you have two radicals on the same side, the very first thing here I would do is move one of the radicals on the other side. That'll make it easier to square. So let's come up with a principle or a property that we may need. If the bases are equal, if A is equal to B, or in this case, if 2 equals 2, then the exponents will be equal. So I know that x squared has to equal 5x plus 6. Well, if x squared has to equal 5x plus 6, then I could solve for this. X squared minus 5x minus 6 equals 0, and then I could factor this. Factors of 6 that differ by 5 are 6 and 1. And so I can come up with some solutions. X equals 6, x equals -1, and of course I would want to check these back into the original problem. So the principle that I wanted to show you was if the bases are equal, then the exponents will be equal. So let's take a look at our first example. The first thing we want to do is try to isolate the radicals. So I'm going to undo the addition subtraction. There's nothing being multiplied, so I'm not going to divide anything, but it is being squared. So to undo squaring, it is being square rooted. So to undo square rooting, I'm going to square both sides because the square root of m squared is just m. And over here I get 36. And of course I'd want to check that. The square root of 36 really is 6, and 6 plus 3 checks. Yep, it is 9. So it's true. So the solution really is 36. So be careful. Whenever you square both sides, you need to check your answers because you might be squaring a negative, which turns out to be positive, but then if you check it again, it doesn't work. So squaring or raising something to the 4th power, I would be checking the solutions. So we've isolated the radical. It's on the same side, so let's subtract 1 from both sides. X minus 1 will equal the square root of x plus 5, and there's a huge trap here. A lot of times students think, well, I'll just square both sides, and they think about maybe distributing this 2, but that's a huge no-no. We can't do that. And I know why students are thinking that, because if you have like 5x in the quantities being squared, then you can distribute it if it's multiplication. So that is 25x squared. But over here we cannot distribute. So either write it out twice, because that's what squaring means, or if you could memorize a nice little rule and it says square the first term, and then it's twice this product. So it's the product of x and -1, and we'll double it. Well, x times -1 is -x, and then if I double that, I'll get -2x, and then square the last. So again, the rule is square the first, twice the product, square the last. You're going to be doing this often enough. I know you don't want to learn a new trick, but you're squaring so often. Get to know this. So if I have x plus 5 squared, I would square the first term. It's twice the product. Well, the product of x and 5 is 5x, and just double it. 10x, and then square the last. That's a lot faster than FOIL. Again, the rule is square the first, twice the product, square the last. It's a nice trick. You may want to try to learn something new here. So I'm going to subtract off x from both sides. Try to subtract off 5 from both sides. End up with a -4. And then look for factors of 4 that differ by 3. I think that's 4 and 1. Signs are going to be different. The larger one is negative. And we get x equals 4 and x equals -1. But I want to check these answers because, not because I have a negative answer, but because I did this. I squared both sides. So sometimes positive answers work, sometimes negative answers work, so I don't want you to think to always throw out negative answers. But in this case, I think we are going to throw out the negative answer, because if you throw in a -1 right here, I'll get the square root of 4, which is 2, and 2 plus 1 is 3, and 3 does not equal the x value, -1. Check the 4, and I think it works. So here's the author showing you the check for these. And we get a false statement over here. 3 does not equal -1. So what do? You throw out that and say the only solution is 4. This is called an extraneous solution. It's an extra answer, and that's how you spell extraneous with the word extra, and that's exactly what it means. So over here, I'm going to undo the 2 by adding 2 to both sides. Next, I'll cube both sides because the cube root of anything cubed is itself. So 3x plus 4 is equal to 8. I'll subtract off 4 to help simplify what's happening to the x value. And then I'll divide through by 3 and I'll get 4/3. That's a little bit harder to check, but I think it will check. And because you raise both sides to an odd power, I'm not so concerned about extraneous solutions, but you should still always check your solutions. So here's some steps, strategies, and procedures to help solve radical equations. You can pause the video and read through those. Again, as I mentioned before, if you have radicals on the same side, you'll want to try to isolate one of the radicals. So I'm going to try to move this negative over to the other side of the equation by adding it to the other side, and that'll make it a positive. So, sorry, miswrote here. So this is a -2 still. The next thing I want to do is try to square both sides. Well, the left side's really easy. I get just x plus 3 because anything quantity squared is itself. But over here, I have to be very careful. I can't do this red distributing. So I'm going to try to use that rule that I showed you before, which is square the first. It's twice the product. Well, 1 times this is the square root of, but I'm going to double it. So it's twice the product. And then it's square the last, which is kind of nice because when I square the last, I just get x minus 2. Remember, the square root of x minus 2 quantity squared will be just x minus 2. So I'm going to combine some like terms. X plus 3 is equal to, I'll combine the 1 and the -2. So this is an x minus 1 plus 2 square roots of x minus 2. And now the goal is to isolate the radical again. So I'm going to try to get, in fact, I'm going to leave this 2 on this side too because I don't want to work with fractions. But I'm going to subtract off x from both sides, which is kind of nice. I'm going to add 1 to both sides. So the x is actually canceled. And because it's not going to give me a fraction, I think I will divide through by 2. And for the second time in this problem, I'm going to square both sides. So I'll have 4 is equal to x minus 2, and then adding 2, I'll have x equals 6. Now I squared this problem a couple times. I squared it up here, and I squared it down here, so you definitely want to be checking this answer. It's simple. 6 plus 3 is 9. The square root of 9 is 3. Minus 6 minus 2 is 4. Wait a minute. 3 minus 4 is -1, and I had a positive 1. Looking back at the slide, I forgot to take the square root of this. So this is really a 3 minus 2, and that checks. That really is a 1. The author is correct. 6 is a solution. Sometimes I find some mistakes in these slides, but this is not one of them. So 6 is a good solution. This was 9 is equal to, the square root of 9, I almost did it again, is equal to 2 plus 1. So 3 equals 3, and that does check. If you have radicals on both sides, that's a good thing. But remember, when you square both sides, we can't distribute this exponent, which is what students usually like to try to do. So don't do that red step. The left side's easy. The square root of anything squared is just itself. That's x minus 2. The right side is a little bit more difficult. So let's do that rule again. Square the first. -2 times -2 is positive. It's twice this product. Well, the product of -2 and the square root of 2x plus 3 is just -2 square roots of x plus 3, and then I got to double that. So it's -4 square roots of 2x plus 3. And then when I square the last, I get something nice, just 2x plus 3. If you don't like this rule, you could always just go, and it takes a little bit longer. You would have to write this out twice and FOIL it up, but that takes much longer. So the goal now, if you are down here, is to get the yellow all by itself. And to do that, I can combine the 4 and the 3, which is 7, and then I'm going to subtract off 7 from both sides. giving me a negative 9 on this side, so I'm done with the numbers. I'll subtract off 2x, leaving me with a negative x on this side, and I have a negative 4 square roots of, I'm not going to divide through by negative 4, but I can divide through by a negative 1. This will just make the problem just look a little bit nicer. So I'll get x plus 9 is equal to positive 4, 2x plus 3. And again, if I divide it through by the 4 to isolate the radical, you're going to end up with a 9/4 over here and a 1/4 x, and I would avoid that. We'll just square both sides like it is. Remember, we can distribute that on the left side. We just can't distribute over here. So on the on the left side, I'll do the formula that I've been trying to teach you in this video, which is square the first, twice the product. Well, the product of x and 9 is 9x, and we'll double it. Square the first, twice the product, square the last, is equal to 16 times the quantity 2x plus 3. I can distribute the 16 over addition. I just can't distribute exponents over addition, but 32x plus 48. I'm going to subtract off 32x from both sides, leaving the x squared minus 14x. I'll also subtract off 48, giving me a positive 33, and I think I have a 0 now over here. So the goal is to try to factor this, and again, if you can't, then I have to use the quadratic formula or a graphing calculator. Factors of 33 I think exist. I need factors of 33 that add up to 14, and I think 3 and 11 will work well. Those are factors of 33 that add up to 14. This says signs are going to be alike. They're both negative. And I did square both sides, so I definitely want to check both solutions back into the original. I think both of these answers, the author gets the same thing. I think you can go back and perform these checks for yourself, but they will both work. If you don't want to perform the check analytically, you could go verify your work graphically and check your solutions on a graphing calculator. All I did was the left side I typed in under y sub 1, and then the right side I typed in under y sub 2. If I trace or graph this, I can see the two functions. They're almost lying right over each other, so it's hard to see their points of intersections, but if you go to second graph and look at where I think that the solutions are at, which are x equals 3 and 11, you can look at 11 first here, and sure enough, the intersect is 3 on both. And then if I come down here, if I let x be 3, I can see that the intersect for both is 1. Sorry, my calculator's going a little bit slow. Again, you can try some zooming techniques here to try to clean this up a little bit, but it's easier just to look at the graphing calculator. So again, one last example. I would try to get one of these radicals on the other side. I'm going to choose to move this one over, so I'm left with 3x minus 5 plus 1 equals negative 2x plus 3. If I square both sides, which means I'm going to have to check the solution, squaring the left, I'll get squaring the first twice this product, 2 times 3x minus 5, squaring the last, is equal to a positive, because negative times negative is positive, 2x plus 3. Next, I want to isolate this radical again. And I can do that by combining like terms. There's a negative 4 on this side, so I'm going to add 4 to both sides and subtract off 3x for a negative x. And I'm left with this yellow blob, which again, I wouldn't divide through by the 2 because that'll create some fractions. I would simply just square both sides again. This distributes 4 times the quantity 3x minus 5, which is really 12x minus 20, should equal squaring the first. Twice the product is going to be a negative 14x squaring the last. Let's set it equal to 0. I'll leave the x squared alone. Subtracting off 12x gives me 26x, and then adding 20 gives me a 69. I'll try to factor. Factors of 69 are 3 and 23, which works because that adds up to 26. So 3 and 23, I'll say x minus x minus. So I'll check x equals 3 and x equals 23. I've got two possible solutions. It just so happens that neither one of them work. And so they're both extraneous. So I would say that the solution is the empty set. You can graph it and see that the two functions never intersect. Perhaps you would look at this from the get-go and say, well, I knew that from the very beginning because, look, the square root of anything has got to be a positive number, plus the square root of this has got to be a positive number. And if I were to subtract off this 1, that's got to equal -1, and positive plus positive will never equal a negative number. So maybe you knew before you even did all this that the solution was the empty set. Yeah, there's no solution in this particular problem. The last thing I wanted to end up with is some applications. Sometimes we have formulas that deal with radicals, and here's one that deals with sound and how fast sound travels in relation to the temperature in the room. So if they give you that the temperature is 74 degrees, we're just going to plug that in for the temperature and just evaluate. And honestly, I would do this on my calculator. It's just a bunch of number crunching here. But if you type this into your calculator, you'll get the solution very quickly. So I honestly would not take the time to find out that that's 370. You're eventually going to pick up your calculator anyways because nobody knows the square root of 2827. But if you were to type this in, you're going to get somewhere around 1164.4 feet per second. But again, I would have gone to the calculator right from the get-go. I would not have done all the number crunching. I hope you found this video helpful. Email me with your questions. Thanks.